Hello, everyone, and welcome to Global Hack Week. It appears as though my camera is not on. There we are. Okay. Hello, everyone. Welcome to Global Hack Week. I'm super excited to have everyone here and see everyone in the chat. How's everyone's Global Hack Week been going so far? I know today's the first day, but I'm really excited for Beginners Week. I love learning new things, and especially a whole week geared towards learning new topics at kind of like an intro level is super exciting for me. All right. In the meantime, while I'm waiting to hear back from everyone in the chat, I'm going to get straight into it, kind of give you all an explanation of what we'll be doing today. Today's stream, we're going to be doing an introduction to data structures and algorithms in Python. Awesome. I love to see that everyone's excited for Global Hack Week and their Global Hack Week is going well so far. Love to hear it. This is the first part of a 3-part series. The entire thing will be in Python. It will be covering different data structures and different algorithms, and they'll be getting more advanced as the stream series progresses. Ooh, it looks like Lily went to the CLI stream, which is very interesting. Love to see that. Yes. Oh, you didn't see a Global Hack Week announcement for this. I will send the check-in link in the chat as well as make a announcement for this in Discord. That slipped my mind. So I will go on to the next slide. So y'all can get the check-in link for today's stream, and I'll also put that in the Discord so you're able to see that after the fact. Thank you for flagging that. So the check-in link for today's stream is just going to be bit.ly/GHW-DSA-Pi1. I know it's a little bit long, but it's a little bit easier to type in than the normal check-in link. So this is the check-in link for today's stream, and I'll make a quick announcement in Discord right now. And again, thank you for flagging that. All right. Just finishing up that quick announcement. Hope y'all are able to sign in for today's session. And again, sorry for the confusion. This slipped my mind when I was preparing for today's stream. All right. Okay. So now we're back. All right. Welcome again to an intro to data structures and algorithms within Python. I'm really excited for this stream. This will be a very basic intro to data structures and algorithms in Python. This is like a very foundational skill for engineers, both for actually finding a job and being an efficient engineer when you actually land that job. I found that when when I was previously prepping for interviews and doing more leak code problems and just diving into data structures and algorithms a little bit more frequently and studying everything, I found myself able to find quicker solutions to problems when I was building a website or doing scripting in Python because I had the algorithms and these like the core foundations of data structures fresher in my mind. So while they are very useful for landing a job and technical interviewing, they do make you a better and more efficient engineer as well. And for those of you who are beginners to data structures and algorithms, which should be most of you, as this is Beginners Week, I'll give you a quick run through of what both of those are. A data structure is a defined way to organize, store, and manipulate data in the memory of a program. So these are things like lists or arrays, dictionaries, hash maps, linked lists, strings. Yeah, those are a few that come to mind. There's many more, and they also have many different names depending on which language you're programming in. A list and an array are the same thing, but they'll just have like different names essentially based on which language you're using. And that is the case for a few different types of data structures. So sometimes I'll use those interchangeably. If you have questions, feel free to drop them in the chat about that and more broadly about any questions. But yeah, I know that like a lot of times with the syntax, if you're especially switching between different languages, the names of things can get a little bit mushy. And as far as what an algorithm is a step-by-step programmatic rule for solving a problem. And that's kind of like the two things we're going to be covering today. We'll walk through some basic data structures and some few introductory algorithms for part 1, and then later on, in parts 2 and 3, we'll be diving into more advanced algorithms and talking about some new data structures. As far as who is leading this stream in Global Hack Week for y'all, my name is Gabriella. I'm a coach here at Major League Hacking. And outside of that, I'm also a full-time software engineer. Outside of tech stuff, a fun fact about me is I'm currently working through the Artist Way. If you're unfamiliar, it's a 12-week program where you kind of dive more into creativity. And I've been really enjoying that since the new year has begun. And kind of as a call out to some links that are on the screen, if you joined us a little bit late, the links on the left-hand side of the screen are the check-in links for all 3 parts of the stream. Don't check in for parts that you have not attended yet. Don't check in for part 2 or part 3 yet, but they will be there when we come back later this week. And then the link on the right-hand side of the screen is for today's slides. You're able to reference those later. You don't need to panic and like quickly jot down that link. I'll have a link displayed at the end of this stream as well, but I just kind of wanted to call out what those different links are. Are there any questions so far? Is everyone hopefully able to sign in to today's session? All right. Thank you. I took a template from Canva and kind of altered it for today's slides, but I'm glad that you like them. Awesome. And we have some enthusiasm for data structures and algorithms from Freddie, so love to see it. Awesome. So let's kind of go on to our next part of the slides. So kind of as an experience check for everyone who is attending today, I'd like to see, first of all, do you know Python? That'll be my first question. Yes, no, or a little bit. And you can, I guess, put those in the chat if you know Python, if you don't know Python, if you know a little bit of Python. And a question that we have as for why I chose Python for the language for today's instruction. It's my best language, and I also have found that it's a really great language if you're technically interviewing at like different places to look for software engineering jobs, just because Python is a very, like, it's the closest language to just like plain English. So it's very, like, I feel like it's easier to do technical interviews in, because it's more simple of a language. And also I'm the most familiar with it because I use it on my 9 to 5. It looks like we have a lot of people who are familiar with Python, a few people who are somewhat familiar with Python, a little bit. Okay. Someone is familiar with Python, but a bit rusty. This is all totally okay. Just wanted to kind of check in with everyone before we got started, so I kind of had an idea of how much I need to dive into explaining things, as it is Beginners Week, but I want to make sure it's a little bit more tailored to everyone as well. And then my second question before we dive into the actual bulk of today's stream is, have you ever leak coded before, or have you taken a hacker rank before? Both of these are pretty common ways to take technical tests during a technical interview process, as well as for different courses in universities related to data structures and algorithms. So the answers to those are yes, you've done both leak codes and hacker rank assessments. No, you haven't done either of them before. Or third option, you've done one of these before. And this is just kind of to gauge how familiar everyone is with solving data structures and algorithms problems. All right. Okay. I believe I answered this, but just as it's essentially like a DSA problem. Hacker ranks are more test-based, where you're taking like an hour-long assessment, either for a university class or when you're interviewing for a job, and leak codes are just kind of practice problems for hacker rank type assessments or live technical interviews. Also just to kind of better your understanding of data structures and algorithms. Some people do them for fun as well. I do them on occasion for fun, but not as often as others. Okay. We have some guesses. Someone has done one of them before. Looks like Quackers and Cheese prefers Code Wars over Leak Code or Hacker Rank. I think I've used Code Wars a few times. I know it's like another data structures and algorithms website. If you could drop in the chat like what the difference is between Hacker Rank, Leak Code, and Code Wars, I'd be curious. Looks like someone has done them but needs more consistency. Leak Code, no, someone hasn't done any. Hacker Rank, yes to Python, and Leak Code, no Hacker Rank. Okay, someone is on day 8 of a leak code streak for the whole year, hopefully. Good job, good start to the year. Awesome. And for any questions that I ask either now or later on in the stream, just drop them in the chat. I'm just asking them as kind of a way to gauge everyone's experience and kind of see where we are with the stream so far. Awesome. All right, so it looks like most people have a little bit of experience with Python and a little bit of experience with leak code, which is great, which means we can spend a little bit more time problem solving than going through all of the core, I guess, like functionalities of data structures and algorithms. But if you haven't worked with Python or leak code before, don't fear. This is a beginner stream, so we will be going over all of them, just maybe spending a little bit less time than we would have before. And for the slides, don't worry. At the end of the stream, I'll have a bit.ly link where you're able to access all the slides, and as well as check in if you were a little bit late to the stream. All right, so here's what we'll be doing specifically today. So we're going to be going over strings, arrays, and dictionaries as data structures. And then we're also going to be going over the sliding window algorithm and the two-pointer algorithm. And we'll also be going over some practice problems. I have them as the last item on the agenda. That's where we're going to be spending the bulk of our time together towards the end of the stream, but we'll also be doing them kind of throughout after I've introduced y'all to strings and arrays, just because there's a few basic problems that don't necessarily have a structured algorithm for them. All right. And here are the practice problems we'll be going over. There's 2 string problems right here. I'm going to just click on the first one and kind of talk through what a string is, and we can dive straight into solving these 2 problems. And then I'll come back and explain the 2 algorithms that I talked about later. And if you have any questions throughout the entire stream, just drop them in the chat and I will answer those as soon as I see them. I am switching between screens when I'm streaming, so if there's a little bit of a delay in answering, that's why. Okay. Okay, it looks like, yes, it is screen sharing. I'm going to refresh the screen. The solution y'all saw earlier is a very kind of like I don't know, it's a more advanced solution and not necessarily what we're going to be going over at first today. I've solved a lot of these problems before, so we'll be clearing those previous solutions out. And also at the end of the stream, I'll have all the solutions we worked on together available in a GitHub repository if you'd like to go over them after the fact. Okay. And someone's asking, do we need to open up an IDE and code along with me? If you'd like, you're able to do that, but you can also just follow along if you'd like. And I'll also send out the links to the problems we're solving if you'd like to open them up and code together in the actual LeetCode browser. But if you just want to follow along, that's okay as well. So this is the problem we're working on now. Okay, so for those of you who are new to Python in general or new to coding in general, as this is Beginner's Week, I'm going to provide a brief explanation of what strings are before we actually dive into this problem. So we can ignore the description on the left for a little bit because this is about arrays. So I'll walk through both what a string and an array are. And then we'll dive into the problem solving. This is just for anyone who is new to coding or unfamiliar with Python. Okay, so strings, for those who are unfamiliar, are a data type that is just house different characters that make up sentences or other text-based data. So this is a string data type. This is a very simple one, but just like hello world, that just holds the text hello world. Some other ones would be like first name, and then it would be Gabriella, that's my first name. Something along the lines of welcome statement would just be welcome to the Marriott Hotel. Enjoy your stay. So for those of you who are unfamiliar or new to Python, this is how you'll house information like first names, last names, any text-based information that will be going on to web pages, emails, if you're parsing through different information that is text-based. Sometimes that's from an Excel sheet. Sometimes if you're web scraping, things will be housed in a string data type. And that's like just kind of generally what a string is. A list or an array is similar to what you see right here. This is a nums array. And these house any amount of things. They're a little bit more unstructured as far as data types go because you're able to put in duplicates of values and you're able to house multiple different data types as well. And you can even have things such as a 2D array. So I'll show you what that looks like. So my test list, I'm kind of switching between list and array. They're called both in different languages. And because when I first learned, I learned with array versus list, they just kind of get jumbled in my head. But again, if that's confusing, be sure to ask any questions throughout the entire process. So this will be, I guess we can just have this be like a number, like a basic numbers array. So for example, Friday spending. So you want to keep track of how much money you spent on a Friday. Say you woke up and you took the train to go to work, and then you bought a coffee. And then you packed a lunch and you were just at work all day. So you didn't spend any money for the rest of the day. And then you spend another $3 to get home on the train. And then you buy some paintbrushes for, I don't know, $8. And then later in the day, you go to meet with your friends to go to dinner and you spend $25. So there is your Friday spending. See, these are a bunch of numbers, but you can also do things like 2D arrays, which I'll show you real quick of what a 2D array would look like. Example, 2D array. So in this case, this is just an array within an array. So this will be something like 0, 1, 2, 4, and then this is not properly closed. But if you were to have it like something like this, you can have different lengths within the array to have multiple housed within here. These get to be, these make more sense when you're working with different amounts of data where you want to group them by different characteristics, and also where like a nested for loop type situation would be useful, which I'll explain more in depth as we come across that. For both strings and arrays, you can access them via the index number, which if you're unfamiliar or you're new to coding, an index number is the location at where that number or that character is within a string or list. And everything is 0 indexed in Python and most coding languages, which doesn't make a whole lot of sense before you start coding, but after you've been coding for a while, it just kind of becomes second nature. There's a very popular LeetCode problem that's 1 indexed instead of 0 indexed, and every single time I solve it, even though I think I read all the directions very thoroughly before I get started, I don't. I inevitably skim past that part and then get the problem wrong on the first try because I have it 0 indexed instead of 1 indexed. But just as kind of like what that means in like a more practical sense. So the indexes for Friday spending would be like this. So the number 3, that would be at index 0. And then the number 5, that would be at index 1. And then the second number 3 would be at index 2, and so on. And then kind of as like another common, I guess, thing you'll need to be aware of is that frequently when you're accessing the last index in an array, it'll be not the length of the array, but the length of the array minus 1. So a pretty easy way to access that would just be instead of accessing Friday at 0, which would be the first item, you can do Friday at -1, just because it'll be the length minus 1. You'll go to the very end. As far as like how that works when you're accessing different items within the array, you'll access them like this. So I'm just going to print out Friday spending so everyone gets a good idea of like what it will look like as an item. And then you want to print out all of your transactions related to do with transit. You're filling out a reimbursement form because you get transit benefits at work, which is a pretty common thing. But I don't know if this would be beneficent or typical way to do this, but we'll just say this is how you're doing it for the case of this example. So here we have Friday spending at index 0 and Friday spending at index 2. And then we also are going to expense your paintbrushes because you needed them for something at work. So that will not be at index 8. That's going to be at index 3. And then similarly, I'm going to talk through accessing an item in example 2D array, just so you can kind of see how a 2D array will differ from accessing different indices. So I'm going to print out the example 2D array, and then also print out example 2D array at index 0. And then I'm going to comment this out for a second, just so we're able to see this. Because I'm in the LeetCode browser instead of a normal IDE, we're going to get a message that some tests are failing. We can ignore that for the time being until we actually dive into our problem here. Okay, so wrong answer. We don't care about that right now. So here is the SD out. This is just the print statements. So we have 4 print statements, as we have right here. Our entire array, yay, and then all of these individual items that are printed out from those different indices. And then for our 2D array, as far as like how that is going to vary, we'll print out our example 2D array, ignore these failing test case for the time being, and then we're going to print out the example 2D array at index 0. And as you can see, we see the entire nested array, as that's what's at index 0, and you'll see that for every item. So if you wanted to access an item within the nested array, so if you wanted to access one of the zeros, it doesn't really matter which 0 in this case, you would need to do, like when you're accessing the indices, you'll need both the indices at which it is in the larger array and then within the nested array. So we have 0, 0, that's accessing the first index in the overall array, and then the first index within the array at index 0. As you can see here, now we're getting that number. Awesome. Okay, so that is kind of the basics of arrays. Yeah, and strings, we'll walk through a little bit more of strings in our other problem, I believe. Yes, a valid anagram is a string problem. Let me pull that up, see if it would make more sense for us to do valid anagram first, just kind of our beginner problem. Yes, I think this might make more sense to start with, and then we can go into our array problem secondary. Okay, I'm gonna check for any questions. Okay, someone's getting an error with the link I posted. I'm not exactly sure where that's coming from. I just copied and pasted that into the browser or into the chat. So all the links to this are posted on the slides. So I would try after the fact in the slides, but if you're still getting an error then it might be, I don't know, a browser specific issue. You might need to restart your browser or something. Okay. So now on to our first practice problem. I'm going to send this one in the chat as well. If you'd like to follow along in real time in the browser and run test cases with me. But like I said earlier, all of the code we work on today will be put into a GitHub repository, so you're able to walk through it and run it yourself if you'd like to. If you're not able to completely follow along with everything live in the moment. Okay, so here's our first problem. It's a string problem. Also, as like an aside, if you're new to LeetCode, kind of as an explanation for how it works, you'll have the description, like what it's labeled as. They typically tag everything. There's a description, an example of the problem, any constraints they might have, and then some follow-up test cases, some more information, like your submissions and then potential solutions, but you don't want to look at those unless you are really stuck and have been trying for like half an hour. Is usually my rule when I'm practicing for any potential interviews, just because then if you're, my, I guess, philosophy is that if you get really stuck at something for, say, half an hour, 45 minutes, and you're really banging your head against your desk, and then you look up the solution, you're less likely to forget it the next day or within a few weeks, because you spent so much time frustrated on it that when you finally figure out the solution or you finally see the solution, you're able to walk through it and like really understand it because you spent so much time like thinking about it from a bunch of different angles. And I found that to be more effective, in addition to also going back and redoing problems that you weren't able to solve very easily, either on your first attempt or it took you 30 to 45 minutes to solve it the first time. It's definitely worthwhile to go back and practice things if you're interviewing. If you're just doing leak code and hacker rank problems to become a better engineer, all that isn't necessary, but all of this is useful for both. Okay, so here is our problem description. Given two strings named S and T, return true if T is an anagram of S and return false otherwise. And for those of you who don't know what an anagram is, or for those of you like me who may need a refresher, because it's been a while since you've done this problem, an anagram is a word or phrase formed by rearranging the letters of a different word or phrase using all the original letters exactly once. So in this case, we know that all of the items in the string are going to be used exactly once, and they can be rearranged, so it's not necessarily something where we need to keep everything in order. So we just need to make sure all the letters are used exactly once, there's no extra letters, and we're not skipping any letters from the past. There's a multitude of ways to do this problem, as I've done this problem a multitude of ways. So I'm just going to kind of walk through what is immediately coming to mind for me. And then y'all can ask questions. Y'all can make suggestions as well if you think of something that you think might be more efficient or makes more sense. And if we, at any point throughout this entire series, go through a problem with the brute force solution, then we'll go ahead and refine it to make sure it's a more efficient solution, or maybe a more elegant solution that you'll want to use if you're doing this for interviews. You should be getting a different problem from the different links. These are the two problems we're going to start with. One is an introduction to string problems, and one is an introduction to array problems. Okay, so my first, I guess, idea for these is to use a dictionary to get a count of all of the letters that are in this anagram, or not as anagram because we don't know it's an anagram yet, but to use a dictionary to essentially calculate the counts of all the characters in the particular string. And then we're able to go through and see if the two dictionaries contain all the same letters and all the same lengths. A good question from Lily before we get started on our solution for this is, what is a brute force solution? So a brute force solution is essentially a solution to a leak code or a data structures and algorithms problem that passes the test cases, or most of the test cases. And the reason it's not passing the last few test cases is because of space or time complexity issues. So an example of that would be if you're using a nested for loop, when you're able to do it with a single for loop or in a different approach. But essentially, it's when you're writing overly complex code to go through the data structure to solve the problem, when you could be doing it in a more simplistic way and not going through the entirety of the data, or not going through the entirety of the data multiple times, if that makes sense. So it's essentially a correct solution or an almost correct solution. Sometimes I'll see brute force solutions don't entirely pass all of LeetCode's test cases because of the space and time complexity issue. But essentially a solution that isn't the most efficient or isn't the most elegant, but it still gets the job done. And you'll want to try, in technical interviews, try a brute force solution initially if you can't think of a more efficient solution off the top of your head. And you can go through that at first, and then if you're able to successfully solve the question with brute force and you still have time left in the interview, you can go through and refine it to a more elegant solution, one that has better space and time complexity. And for those of you who don't know what space and time complexity is, that's totally good. This is a beginner's week stream and an intro to all of these concepts. We'll be talking about time and space complexity on the latter half of part 2, or maybe even the part 3 of this stream, as that is kind of the icing on the cake for most technical walkthroughs in an interview. Sometimes interviewers will ask you about the space and time complexity of a problem, but it's after you've successfully solved it. And can you use libraries in LeetCode? I typically don't, just because you're usually, you don't want to be using libraries in a technical interview. They want it to be more kind of like basic knowledge of syntax and problem solving in a like just solving a problem with like basic algorithms or basic functionalities of a data structure that are kind of built in to Python or JavaScript or Java or whatever language you're interviewing in. But it might be technically possible in LeetCode for you to import a library and use it. So that is the quick answer to that. Okay, so now let's actually solve this. When I'm going through an interview or even talking through a problem when I was in university classes like this, I like to write out kind of like what we're looking to achieve and the different steps I'll take before I actually start coding it out. Because then I'm able to make sure that the whole problem makes sense. I'm accounting for everything. And then also if there's any weird edge cases that like I think of before I start coding, I'm able to kind of go through and like preemptively solve for that. And also if you are going through a technical interview, it's always advisable to talk through your thought process and your solution, because they're not looking for engineers who can do things perfectly the first time when they're faced with a problem, because that's not going to be anyone. They're not necessarily looking for someone who can memorize the solution to a bunch of LeetCode problems, but they're looking for engineers who are able to problem solve and correct themselves in real time and ask questions about the edge cases, about something like they might not have thought of before, and also looking for people who will ask follow-up questions when given different constraints. So that's another thing. When you're going through a technical interview and you're asked a question and you don't fully understand it, make sure you ask follow-up questions versus diving right into it and trying to figure it out that way. And also ask clarifying questions. Even if you feel like you understand the entirety of what you're being asked, make sure that you like ask like to confirm this is what I'm looking for X, Y, and Z. So in this case, I would ask something along the lines of, so I'm receiving 2 strings as the input, and I'm not going to be printing out anything. The only thing that this function needs to be returning from this solution that I'm creating is a binary true false return statement. There's nothing else that should be returned. And in this case, it says that the constraints are the length of T and S are going to be reasonable somewhat. This is kind of a long string, but make sure that it's not going to be like an entire novel, essentially. And that it will be all lowercase letters. So you can repeat that back and make sure the interviewer confirms that. Maybe they'll change things up or correct you if you maybe misinterpreted the question at first. Okay, so right here, we are looking for true, false are strings, are an anagram. That's not how you spell anagram. Will be returned, not printed. And as far as what we are receiving, we're receiving 2 strings. And then as far as the steps I'll be taking, step 1 is I'm going to create 2 dictionaries. These dictionaries are going to house the counts of all the characters in our strings. So I'll have something to the effect of T dictionary and S dictionary. And then after I do that, I'm just going to check really quickly to see, check if the length of S and T are equal, because something can't be an anagram if they're different lengths, because they need to reuse all of the same letters exactly as many times are in the first string. So if they're not the same length, then they're definitely not an anagram, and we don't need to go through the rest of that. But after we've checked that, if not, we're going to return false. But if they are equal, we're going to proceed, and we're going to proceed with a for loop. So the for loop is going to be the length of S and T. And within this loop, every single time, what we're going to do is we're going to iterate upon the count of the character. So the way that initially comes to mind, and will initially come to mind for most junior engineers, is to check to see if S at the index that we are in within the for loop is in dictionary. We're going to increment, and then otherwise we're going to append SI equal to 1 into our dictionary. And then kind of just do the same thing for T. And then once this for loop is done executing, we're just going to essentially see if our dictionaries have equal counts of the different characters. Something we do need to account for in all of this is that on occasion, or I guess not on occasion, most of the time when you have 2 anagrams, they're not going to be in the exact same order. So we're going to want to ensure that these 2 dictionaries are being compared equally. I'm thinking of 2 potential ways we could do this. The first way that would probably come to mind for a junior engineer would just be to check, or would be to sort both dictionaries. This is a built-in function within Python. That'll do this in alphabetical order. If the built-in function is to my memory, then it will sort both the dictionaries in alphabetical order. So it'll be A, the count of A, B, the count of B. And if that is not the case, I have another edge case or another solution to that problem. And then after we have sorted both the dictionaries, we're going to check if S dictionary is equal to T dictionary. And we'll just be returning whatever this is. So returning S dictionary equal to T dictionary. If they're not equal, it'll return false, which means that there's a difference in the count of the characters in our strings, so it's not a valid anagram. And if they are equal, that means we do have a valid anagram. Someone is asking, shouldn't we check the length before creating dictionaries? If they're not the same length, they are already disqualified. We could put them before that. It doesn't necessarily change the time complexity of this at all. I just wanted to essentially put it before the for loop, so we save that execution before. So we're checking before that more lengthy execution. It would save us a little bit of space complexity. So it could go either way. Probably slightly more efficient to put it before creating the dictionaries. We can switch that order later. But thanks for pointing that out. And also, if y'all see anything that looks to be a little bit off or you think could be done differently, please put stuff in the chat. This is meant to be a learning experience for everyone. I'm not going to just have the immediate solutions and put them up on screen where I'm talking through them and explaining things. So something doesn't make sense, feel free to ask about it in the chat. All right, so this is the solution. We know what we're receiving in our function. We know what we're looking to output in our solution, and we've made some pretty clear steps. They make sense to me. I think they make sense to y'all. There haven't been many questions on this so far. So now we can get up to actually coding out these steps. So we're going to check if the length of S is equal to the length of T. I'm going to check if they're not equal, actually, just because all we want to do is if they're not equal to return false. And otherwise, we can just execute the rest of our logic for this function. I'm just going to write it out outside of the if statement instead of adding it under an else. It executes pretty similarly, and that way we don't have to worry about indenting everything. So next thing we're going to do is we're going to create our two dictionaries. Oh, also for those of you who are new to Python or new to coding in general, I'll do a quick explanation of dictionaries before I move on from this. Excuse me. So a dictionary essentially houses data like this. So in our case, we're just going to have different characters and the counts of them. So it'll be housed like this. I don't know. So it's similar to this. It doesn't always have to be text with a number as the value, the key value pair. But this is the general gist of how the data is formatted, how it's structured within this particular data structure, and how you access things is like this instead of with an indices. So instead of having an indices, you'll access it via the key of the key value pair. So that'll be A, B, Z, etc. And so y'all know what they're called. Each item in the dictionary has a key value pair. So the letters in this case are the keys and the values are the numbers. And you access them via the keys instead of via the values. Okay, so let me get rid of this. Also, they're separated by commas, similar to in arrays. So that's basics of what dictionaries look like. And also, the different data structures do vary slightly by different language you're using. This is all specific to Python, but the concepts are pretty easily replicable between different coding languages if you mainly code in different language. All right, so now on to our next step. So they are equal. We're going to go through a for loop. So for I in the length of, I don't know, in range of length S, what we're going to do is if S of I is in S dictionary, we're just going to increment that up by one. Otherwise, what we're going to do is we're going to create something new, or we're going to append our character into the dictionary. It's not the same as it is in an array. We haven't talked about that yet. We'll discuss appending in arrays later, but this is how you add items to a dictionary. This is not at where it should be. Okay, so it'll be S dictionary at S of I. So in this case, we're accessing the key at S of I. So in this case, it would just be an anagram, and we're assuming that it would already be in S of dictionary. So I guess the better case example would be the second A in here. We're accessing the A in S dictionary, and we're adding on one. If it doesn't already exist within that dictionary, then we're going to create it and set it equal to 1. We're going to do the same thing for T. There is a more efficient way to do this, but I'm going to walk everyone through this more brute force solution, just so people can get an idea of like how it would be done more basically from the get-go, and then how you can kind of improve upon it. And also just this is kind of generally to get everyone familiar with these different data structures in Python. Okay, so if T of I and T dictionary, okay, I think I changed all of these. And then we're going to sort both of these dictionaries and return if they are equal. It looks like we have someone in the chat who has put in what looks to be like the built-in function for sorting dictionaries in Python. So we will attempt that. If not, I'm going to reference my notes. Okay, so let's see. Return T dictionary S dictionary. And then also for people who are new to LeetCode in general, there's two buttons here. We have the run button and the submit button. The run button runs a few initial test cases, and then the submit button will run more. Usually it's anywhere from like 50 to 100 test cases, just to kind of see if your solution passes the time and space complexity requirements of like the problem they're looking for, and also just like runs a more wide variety of test cases. Oftentimes you'll come up with a solution and it will pass the initial few test cases, but won't pass all of them that you'll find under the submit button, in which case you'll need to go back and refine things. And also when you run things in LeetCode, you'll get, you can add, you used to be able to add more test cases, but now it looks like, oh no, you can. So you can add your own test cases here. So I'm gonna have my name, Gabriella, and then it looks like Shrey also answered, or also asked a question recently. These are obviously not anagrams, but we want this to fail. So this is another test case that I'm creating. You can create multiple. I don't know if there's a limit on them, but if you're curious to see how something will execute, you can go ahead and add test cases to this. All right, so this is, okay, that's expecting false, return false. So it looks like our initial test cases are being accepted. I'm gonna submit this and see if it passes all the test cases. Oh, it looks like we got a wrong answer. So it's passing the majority of the test cases, but not all of them. So I'm curious if it'll show us the other ones that are. But this might be. I wonder if it's this particular sorting built-in method is compressing the dictionary in a way, because all of all the keys, the keys are the same, but the counts aren't the same. So I think that is what's tripping this up. Okay. It looks like in my initial solution to this, I was not sorting the dictionaries, and I believe that passed all the test cases. So I'll try it without sorting to see if we don't need to actually compare them in the order isn't as cognizant as I had, or isn't as pertinent as I initially thought. Okay, so that was the issue. I'm thinking what happened is the sorting algorithm just compressed the dictionaries into just the keys instead of the key value pairs. And it looks like we can just compare the dictionaries, and they're set to be we don't need to have them be in the same order for them to be equal. So yeah, and also for those of you who are curious, LeetCode will give you the runtime and the space and time complexity. The space complexity is the runtime, and then the time complexity is the runtime, and the space complexity is the memory. I don't know if I said it in the correct order before or not. Repeating a lot of the same words, they start to not sound like words anymore. But you can see how your solution compares to the other solutions. Our runtime is pretty good. It's in the 80s. I would say that's a pretty good time complexity. Our memory is not very good. I knew from the get-go that this was more of a brute force solution, so this is to be expected. But this is like where you can kind of see Hello, all. I'm back. I'm not sure how many people are still here after I ran into technical issues. I'm hoping that everything is fixed. My apologies that the stream went black for a little bit, but I'll just kind of try and pick up from where we left off. My apologies. Have an older computer and sometimes run into technical issues. Okay, let me get back to my screen sharing and hopefully we can pick up where we left off. And I guess we'll just have to cover a little bit more ground in parts 2 and 3 than I had initially anticipated due to this interruption. My apologies. Okay. Cool. Awesome. Okay. I think that we are back. So I think I was just talking about before the cutout that the runtime and space complexity of this problem are defined here, and you can kind of compare them to different solutions within LeetCode that other um, hackers have submitted.